currently, this presentation we're going to have Shankar, Manoharan, and Oliver Mao talking about making the perfect pick. We'll see how that goes. Shankar, Oliver, you will take the floor.
Hey guys. Oliver's just turning our presentation on.
All right, that's not it.
Cool. So welcome to our presentation. We are going to talk about known unknowns, scouting to win. So Oliver and I will talk through our presentation. We'll start off by talking about who we are. Who is Oliver?
You're not going to introduce me? Okay, so my name is Oliver. I've been a mentor on 2056 since 2011. I've been part of FIRST since 2005 when I was in grade 9. Right now, I work as an immigration lawyer in Toronto, but I've been part of FIRST for a long time, and primarily I've been doing strategy and scouting and awards.
Cool. Who is Shankar? So I have also been involved with FIRST, actually the same amount of time as Oliver. I joined in grade 10 way back when, and I've been involved with 2056 since 2012. Before that, I was in 188, and then I spent my time here since then. Currently, I live in London, across the pond, London in the UK. I work in supply chain. I try to predict the future and decide how much yogurt people are going to buy. I still stay involved. I've been back to Canada for Champs a couple of years, I guess to Detroit for a couple of years, and I try to help out where I can and still stay involved. Cool. So just in terms of where we're going, just a bit of housekeeping. So we have some documents we're happy to share with you, and at the end of the presentation, you can hop onto the 2056 website to pull them up. We've done some previous presentations that are already hosted on there, and you can find out more online. I think the plan is that we'll have brief breaks to take your questions between sections, and I think the chat's being managed to capture your questions, and we will defer to you when you've got something to ask. So please do ask. Cool. So just to kind of set the scene of where we're going. Let's imagine it's Friday night. You've had a couple of strong days of competitions, and you are ready to work on your pick list to make the best decisions possible to help you make the best pick possible, arguably the perfect pick. And in this situation, you need to have the right information available to make your decisions. And to do that, you have to have the right spreadsheet, the right collection of data, the right summary of all the decisions and information you've been watching for over the last couple of days. And ultimately, to do that, you have to have the right scouting sheet. So this is what you need. So if you trace back where you need to be in the perfect situation right now, you have to have started with the right scouting sheet. And I think there's a good quote here from a prof in my first year who told me that to find the answer, you must know the answer. And in order to be in a position to have the perfect information, you have to really hypothesize how the game plays out when you first learn about it. How do you think that the game is going to play out before it even happens? And ultimately, what do you need to know to make the right pick? And so at the very beginning of the season, when you've gotten a sense of how the game is going to play, you know the rules. You're trying to think about, okay, how do we think that the game plays out, and what do we need to really know to make a decision? And what we say, we generally think that the spreadsheet design governs, the sheet that governs the spreadsheet. So that means that you find creative ways to track whatever you need to do on your spreadsheet because your scouting sheet requires it. And ultimately, good sheet design will lead to good spreadsheet design. So kind of to summarize, you build a good sheet, you have a good spreadsheet, you make a good decision, and hopefully it results in good things. Cool. So we're going to focus on this good sheet part of the conversation to begin with, and kind of progress through about how you make some good decisions later on. So the question is, what makes a good scouting sheet? And we think the key thing is you want to capture every relevant difference between the robots. So what are the subtle points that make one robot better or worse than another? And how can you capture and enumerate and quantify that in a way that when you look at it after having watched tens, hundreds of matches, to say, okay, here's what we can say is a clear difference between them. And then the important point is you want to collect every piece of information needed to plan for, but also against robots. So what are the things that that will help you really nail down your match strategy in game and talk to your coaches? Here's what they do that we can capture, or here's what our alliance can do together that makes us the better team out there over the opponents. So the important question we mentioned is that you ask, what will I want to know this year? You're not asking what can I scout, not asking what can robots do this year, but what do I need to know to make that decision on Friday night to say, okay, I've captured all the things I need to know, and now I can make a decision. And then we kind of finished with saying, as with the robot design, strategy is what determines implementation, not the other way around. So whatever strategy you decide is important is what governs how you go about things, rather than saying, okay, well, we're going to do things this way, so we should change our strategy or sheet to reflect that. And I mean, from these points, we can kind of finish with this somewhat obvious sounding statement that a good scouting sheet is the foundation of good scouting, and which will probably be the good foundation of good strategy and hopefully good results.
Okay, so to give an example of what it means to ask, what can I scout versus what do I want to know, let's look at an example from basketball. So if you're asking yourself, what can I look at this year, you would see basically counting statistics. So it's pretty basic. It gives you good information and you can make some good decisions from it. But fundamentally, I guess when you're trying to plan a strategy, knowing how many points or how many assists a player makes doesn't give you enough information to really plan what they're going to do on, you know, a second-to-second basis. It gives you enough to make some basic decisions, but not enough to really excel. Conversely, if you ask yourself, what will I want to know this year? Instead, you will ask yourself questions like, you know, how effective is this player when you actually play him? And compared to an average player or compared to literally no player at all, what would his impact be of him playing defense? And then if you ask yourself that question, well, forget about how complicated it is to actually answer it. But if that's a question that you start with, and that's what you try to focus on answering, eventually when you do manage to answer it, the information that you get is a lot more useful. You can make, you know, real comparisons between your player here and every other player in the league, the best ones to the worst ones, see where he is, and then see, you know, how you can improve your team based on that. So let's move on to what we consider the golden principles of scouting. It's essentially, when you're asking yourself what you want to know this year, these are kind of the sub-questions that you would need to ask so that you don't miss anything. We do this every year when we're analyzing a game. We do this throughout the year as the play of the game evolves, just to make sure that every piece of information that we will ever want to know is captured. And to reiterate what Shankar's point was before, the question that you're asking yourself is what will I want to know? And it's essentially being able to answer every question that you think is ever going to come up at any point during the season, no matter how small or how big. So, you know, it's things like, will this team cross the autonomous line? But it's also things like, you know, this team compared to this one, which one, you know, shot more balls in fewer tries. It's as specific or as general as you ever want to go. So if you move on, the first point that we'll ask ourselves is, where did every point come from? We've broken this down into a bunch of categories. The first one is the most basic one. So what actions do you do that directly put points on the scoreboard? So this is essentially when a team does this action, the score on the live scoreboard changes, the ref puts something in the FMS to show that a point was scored. This is, you know, irreversibly scoring a point. So things like putting a ball in the goal, things like in 2016, when you go over a defense, the ref puts the point in the FMS, or, you know, crossing the autonomous line, you get those points, and those points are done. Next, what did robots do that enabled points to be scored? So these don't directly lead to points being put on the board, but this is, the proximate cause of points being put on the board. Examples are when you acquire a game piece, you need to do that before you can directly score any points. So that's where we would track that. If you give your game pieces to other teams and then they acquire them, that's still close enough that we would need to track that. We need to at least look at that in our game analysis. Because that's going to lead to points being scored. There are other actions within a game that you can sometimes do that would cause points to be scored. One example would be putting litter into recycling containers in 2015. A more recent example would be in 2019, when you put a hatch onto the goal that enables more points to be scored because then you can put a ball inside the goal as well. And then this is kind of a finer point, but you also enable points to be scored when you do things like build a small robot in years like 2012 or in years like 2019, when you need to, for example, get onto a bridge or the HAB zone, and you can only fit so many robots onto the highest level. So having a small robot, or in 2019 having a vacuum hanger, is going to enable more points to be scored. And similarly, having a ramp in other years like 2018, that's going to let people score more. And the last one that we want to track, or we want to ask ourselves here, is where on the field did they come from? So this is focused on the location where these point scoring and point enabling actions take place. So usually when you score a game piece, it's at a set location on the field. So sometimes for things like gear scoring in 2017, those are always going to be in the same places and you can't really deviate because you can't throw gears. For the ball scoring games, you can score balls from different locations on the field, and sometimes there are relevant differences between those locations. So you need to ask yourself, do I care where this ball went into the goal? And how granularly do I care? Do I want this, to within the foot, or do I want this to within the inch, or do I want this, to within the front of the field or the back of the field? That kind of thing. In autonomous mode, this is different from during teleoperated mode, because of usually there are differences between what teams are capable of and what the point values are in autonomous. And there are also other actions that are not, point scoring actions, but that you still need to know the location of. So our example is in 2015, when you did the can burgling at the beginning of the game, it mattered whether you were, a side can team or whether you were a middle can team, or how many of them that you could get. So those are also things that you can think about. It's not just directly point scoring, but the locations of your enabling actions we want to think about as well. Moving on to where every missed point went. The first one, similarly, the most basic one, is directly stopping your opponents from scoring points. So this means things like in 2016, when you're blocking a shot directly, and then a team took their ball, they tried to put it in the goal, and it didn't go in the goal, and it was directly because of you. Same sort of deal in 2014. We had the goalie polls doing blocking. Blocking is a little bit less common, but in the 2020 game, you could also, in theory, do blocking. Remains to be seen how effective that's going to be. There are other actions that directly stop teams from scoring points is, taking game pieces away from them that ostensibly are assigned to them. So in 2018, the cubes on the side of the switch ostensibly were assigned to one alliance depending on the position on the field of them. And if you took the ones that are in theory assigned to your opponents, you're taking away potential game pieces from them. Or things like, in 2016, there's a similar situation with the secret passage. In 2017, you could take gears from the opponent's retrieval zone that they dropped because they failed to pick them up. Those are all actions that you take that would take away points from your opponents, or the ability to score points from your opponents. The next thing that could happen is you could stop yourself from scoring points. So these are actions like when you make a mistake, when you drop a ball, when you miss a shot into a goal, when you have scored points based on your assembly of game pieces and then you knock them over. So for example, in 2015, we had you build these stacks of totes, and then you put them on the platform. And if a team came by and knocked them over, those points that would have been scored no longer going to get scored. And then the last point, and a finer point, but really important in a lot of years, is you want to ask yourself what actions could have scored points, but score no points, and it's through no fault of your own. So this doesn't mean doing things like shooting a ball and it missing. That was your fault. This is things that you made a strategic decision, or the team may have made a strategic decision to not take that action, and it led to them scoring less points. But if you told them, or if it was the strategy for them not to do that, then they could have scored those points. One example would be, the best example for this is in 2017. Teams had to get to 4 rotors by putting the 10 gears on, but once you got to 4 rotors, there was no point putting gears on at all because they wouldn't have gotten you more points. So a point scoring action at first would have been to put the gears onto the pegs and bring them up, but later in the game, that same action wouldn't have scored you any points. But if, for example, you had a team that wasn't able to put on gears, that aligns, and then another team had to pick up that slack, they could have put on more gears. That's something that you want to think about, because that was a decision that the scoring team made to not score points in one game and to score more points in another game. And you have to know when they're doing that, because just because they choose not to score points doesn't mean that they couldn't score those points at a time when they needed to. The point that we're trying to make here is, with an organized alliance, these teams that have potential points that they didn't capitalize on in the one case would have converted those points into actual points in a situation that requires it. But you might be asking me, but Oliver, why does any of this matter if we're not going to be playing with other teams, if we're playing a one robot game? So building on what Shankar was talking about in the beginning, when you're doing an analysis of the game, you're asking yourself, what will I want to know this year? And just because you're playing a one robot game, or the FRC is going to send us some modification to the way the game is going to be played, you still need to run through the same analysis and not treat it like it's different because you're playing with one robot. You are treating it like it is a different game, but you're not treating it like it's not a FRC game, or like it's not an engineering and strategy problem that you need to solve. So if you look at a game in a regular year or in this year with a single track in your mind, saying, okay, I want to build a robot that scores all these points, and I'm going to branch out from there. You're going to lead yourself to miss things, essentially. So I guess a story that I can tell because it's long enough ago is in 2009, I think was the year. No, 2010. 2010, I wasn't even on this team at the time, but that was the game with the soccer balls. And the restriction on the game was that you couldn't contact the ball with more than some number of inches of grabbing of the ball. Shankar can jump in if he remembers the actual rule. But basically, 2056 that year looked at the game with the ball, decided that they couldn't grab the ball with that number of inches, and then they built this like really complex, amazing mechanism that didn't actually hold on to the ball, but it let them like manipulate the ball, and then their driver skill allowed them to manipulate the ball around the field without actually grabbing it and kick the ball. And they had a really good machine and a good year that year, but they just missed that. Our team just missed that you could actually grab the ball. So if you run yourself with a one track mind, or if you don't do a systematic analysis, you're gonna miss things, and you're not gonna realize this until many weeks down the road, and you're playing at events and you show up, everybody can grab the ball, and you're like, oh well, that's embarrassing. And it doesn't lead you to not be successful, but it's a less effective way than systematically breaking down the game, making sure that you don't miss any possible way that you or your opponents could score or prevent people from scoring points. So if you come at it with that angle, if you think about what you want to know, you'll be able to design in order to do those things. So scouting doesn't just inform, sorry, game design doesn't just inform scouting. Scouting can also inform your robot design. On our team, everything informs everything else. So when we're designing a robot, we'll think about what parts of that we might need to track if they're on other robots. When we're designing a way of tracking other robots, we'll think about, okay, well, if we expect to want to know whether a team can do this action, then we're gonna need to do this action as well. Or if we expect to want to know whether a team is this or this, then we'll want to think about whether we want to be, tall or short, for example, or if we want to be big or small. This leads you to be able to do analyses that oftentimes you wouldn't be able to do. So one example is when you analyze a game, you want to think about not just what the most effective robot is going to be, but what the alliance that is going to win is ultimately going to look like, and how you want to contribute to that. So you want to think about, or at least we think about, what the truly scarce resource is going to be in an alliance, because our goal is to win a world championship, like most of you know. So you would, when there's a niche that can only be filled by 1 or 2 robots, we want to think about whether we want to be in that niche. So one example is in 2016, the truly scarce robot was not a robot that could go under the low bar, like a lot of teams thought, but a robot that could do the sally port and the drawbridge. There were a handful of teams in the world that could effectively do those. We were not one of them, at least with respect to the drawbridge. So we, in the scarcity analysis that we did, we didn't see that this was going to be the truly scarce resource, and maybe if we did, we would have maybe designed our robot differently to be able to accomplish that, because that would ultimately give you 10 more points. And when you're trying to win a world championship, you just need 1 more. Okay, moving on.
Cool. So we'll try to take what we just talked about in those few slides and try to apply to a real world scenario. And we're going to use the 2019 game Deep Space, because we played that in full and we have a lot of information for it. Unfortunately, we didn't get a chance to play a game this year, so we have less information available. But we'll circle back and come to the most recent game. But we'll do a lot of analysis looking at the last fully completed game, which is Deep Space. I will start off by playing a video, which Oliver is popping up. So just a reminder of how the game played out. Just take a watch of the game animation and remind yourself.
Welcome to the 2019 First Robotics Competition and this year's game, Destination Deep Space, presented by the Boeing Company. 2 alliances of deep space travelers race to place hatch panels on their rockets and cargo ship, load valuable cargo for transport off the planet, and return to the safety of their habitat, all before the next sandstorm sweeps through. Each alliance has 2 rockets, 1 cargo ship, and a habitat. Hatch panels and cargo are available through the human player stations, and cargo is also available in the depots adjacent to the habitats. Robots start in their habitat and may be preloaded with 1 game piece. Alliances may also choose to preload some bays of their cargo ship with either hatch panels or cargo. During the first 15 seconds of each match, driver vision of the field will be blocked by a waning sandstorm. So robots must be controlled using either autonomous code or manually with a vision system on the robot. Alliances earn points for exiting the habitat, securing hatch panels, and any cargo that's properly stored. Cargo not secured spills from the cargo ship. As the sandstorm ends, driver vision returns, and alliances continue to earn points by loading their spacecraft. Alliances earn a rank point during qualifying matches for completing 1 rocket with hatch panels and cargo. Near the end of the match, robots return to the safety of their habitat for the upcoming launch and to earn more points. The alliance that earns the most points wins the match.
thanks Oliver for helping us remember. It is a while ago now since we've had a game release since then, so it's a good reminder for everyone, including me, for how that game was played. So we're going to flip through and apply some of the principles we talked about to talk about how it applied to 2019. So we'll start off by saying, where did every point come from? So we're trying to answer what actions were done to directly score points, and there are a few actions the video just went through. You can move in Sandstorm, mobility points there. You can place hatches, you can score cargo, or you can climb. So there's a very discrete and countable number of actions that cause points to go into the FMS, and these are the 4 ones that apply to that game. But how about some more analysis? So what did the robots do that enabled them to score points? So what were the actions they took that specifically resulted in doing those first 4 actions? Hatch intake, cargo intake, you drop some ramps, you elevate to middle, low, or high. You can decline null hatches. You can be small. So this is one of those subtle points where your size can help you be more mobile, and therefore you are able to score more points. And then you can have these vacuum climbs that allow you to get up onto the hat platform and score some points. And where did they come from? So how are you enabling all of those actions to occur? You pick up off the ground, you score into the rocket or cargo ship, and then there are the very, very many different locations into which you can score. So there are, I guess, 2 different locations on the cargo ship, either the sides or the front, and there are 3 different heights on the rocket ship. So many different locations to track. So 3 rocket levels, and then there are 3 climb levels as well. So very, there's a huge, I guess, sample space of different actions you can complete to score points, which is important for scouting when you make decisions. And where did every miss point go? So what actions were conducted that caused points to not be scored? So you can stop your opponents from scoring by causing a drop or a miss. So under heavy defense, you can see hatches being missed or balls not quite going into the rocket ship. You could block access to a rocket ship or cargo ship. And if you think about the championship, there was a lot of this going on. The defense very much picked up. How do you stop yourself from scoring points? What kinds of things do? You can drop game pieces. You can put hatches on too loosely, which may give you the impression that they're good to take cargo, only for them to fall apart once the ball goes in. You could miss your climb, which can be very important because it's your last chance to score some points for the match ends. But then also you have a couple of things that you could put on too many hatches. So if you're putting on hatches when there are levels of the rocket ship that can allow you to score cargo, then you're scoring inefficiently because your cargo scored is worth more than a hatch put on. You can prepare to climb very early. So maybe you decide that the climb points are really important and you go back to climb, but you could have scored another hatch panel. You could have scored another cargo into either the cargo ship or the rocket. So this is more of a nuanced decision where it doesn't necessarily show up directly. Oh, they dropped the ball. Oh, they missed putting the hatch on. They fell off the hat platform. Here you're saying, the decision they made there didn't seem like it was optimal because they could have scored more, or they should have scored cargo instead of another hatch. And then this final rather nuanced point that I was talking about. So what actions could have scored points, but no points were scored as a result. So this one is a bit harder, but the clear one here is that everyone was chasing that rocket ship RP. And so maybe you're scoring inefficiently to try and get an RP, because points on the cargo ship are the same as points on the rocket ship, but scoring on the rocket gets you RP. So if you are going all out to try and get a rocket ship RP, you may be focused on a single rocket ship. You may be fighting with your partner to get access to put cargo in or put hatch panels up, and it means that you're not scoring as efficiently as you could if you were scoring wherever you needed to. And so it may mean, ironically, that the robot that does really well in eliminations was focusing on getting RP, and you didn't realize how well they could score on the cargo ship because they decided to go all out for the RP. So that's kind of where that comes into play. But I think last year's game, we saw it a little bit less frequently, but I think the RP one is a clear indication there where you decided to focus on RP over scoring. I think the clear example of this is with the one Oliver talked about in 2017 with gears. So either you finish 4 gears four orders super quickly, or you get to 3 and you realize, okay, there is no way I'm going to get to 4, so I'm going to go score fuel instead. And so then how do you try to find ways to say, okay, well, how long did they score on 3 rotors and then abandon it? Do you try to use time? Do you try to use cycle times? So there are some options to try and capture that, but that's where you're going to see a strategic decision about how you play the game, about trying to chase RP or trying to win the match, where you don't fully get to see the capabilities of the robot because they made a decision that goes away from showcasing that. So yeah, this is one that requires a bit of imagination and a bit of kind of thinking because it's a little bit more nuanced, and you do have to hypothesize how the game plays out. And maybe this is something you start tracking after seeing a single week of competitions. But I think this is one where you really sit down and think about, okay, so how exactly is this game going to play out, and what would we as a team do that would be the correct decision for the win or the correct decision for RPs, but clearly means that we look less good than we are at scoring. So this is a subtle point, but one that's important to consider because it can really affect how you consider robots, because you can miss a cargo ship score a big time because they were focusing on the rocket. Cool. So once you've made that list of where are the points scored from where the points missed and what are the actions that you've taken that mean that you're scoring less efficiently or at least appear that way, you make a list. So what are the most important things that we need to do, and you rank it. And so what we've done is we've skipped the brainstorming process and made a list that we thought would prioritize, at least in our eyes. And I'll kind of quickly flip down. So a number of hatch and cargo scored, what's your climbing level, your stance or mobility, your hatch and cargo intake location, your scoring location. And we pointed out here, there are 22 distinct locations for where you can score in this game, which is a lot. So that's a pretty tough one to track. Causing opponents to drop or miss. Where are you scoring? Is it high, low, or medium? It's important in this game. There's no difference in where you score. It's all the same regardless of height. Sandstorm scoring location. So where are you scoring on Sandstorm? Again, all of those locations are still available. Maybe this helps you with planning your autonomous mode, so you want both heading for the same spot. So what scoring game pieces are you using, and what order are you putting them up? This is an interesting one to know. Are you being small? Do you have vacuum climbs? Are you too large? How early and how fast do you climb? How successful are you? Do you drop game pieces? Do you have ramps? Are you blocking your cargo ship or rocket ship? A hard one to track, but it's an important one, but not that important because it's at the bottom of the list. Putting on hatches too loosely. So do you put on hatches and run away and then they're not fully in place and the ball comes in and knocks it off? And then do you decline null hatches? So we thought of, I guess, 16 distinct actions here, and maybe there are some that go on that are a little bit more specific, but we thought this is our list. So once you have a priority list, you're going to decide, okay, how easily can we capture all these things? Because in an ideal world, you track every single one of these. But if you kind of go back to the things we said, you have to decide, okay, how realistic is it that we capture all of these things? Can we actually track it? Is there a way to quantify all of this stuff so you can see what's happening? And so we're just going to go through and see how easy or difficult these things are. So the first 4, super easy. You're counting hatches and cargo. You're seeing where teams finish up at the end of their climb. You see if they move in sensor mobility, and you see where they pick up from. So pretty easy to track those. You can argue the location's a bit tough, but you're saying, is it off the floor or is it off the station? So not so hard. Again, so some quite easy ones. So how high are you scoring? Are you small? When do you climb? How successful are you? Do you drop game pieces? Do you have ramps? Do you block a rocket? Are you declining null hatches? So some of these are basically like Boolean answers. Do you have ramps? Yes or no. Do you drop game pieces? Count those. How quickly do you climb? So maybe you're checking what time they start, what time they finish. Did they succeed? So some of these are again, as you're scoring high, you know exactly where the ball is going if you're watching for it. So again, these are not quite as easy as the first 4, but these are still easy to and doable in terms of watching. Then we get into the things that we think are a bit harder. So we omitted this one because we thought it was too much complexity, because you have to say this one on, but it was too loose, because you may realize that it's loose much later. And then it's hard to come back and say, oh yeah, it was this team that put it on. You know, it was 2056 that put it on, or it was 1114. We're not sure which one it was. And it's hard to ascribe the looseness to a certain team. So we said it's something we can maybe watch for, but it's too hard and too complicated to be able to track on an ongoing basis. And then we have the very difficult ones. And so scoring location, 22 of them. Scoring in Sandstorm, 22 of them. causing opponents to drop or miss. This one's tough. You can watch drops, but then it's hard to know that it was a drop caused by someone. So that's why we marked it as difficult, because, okay, what is it that you can do to say, okay, aha, so they were defended and they dropped it. So this is the thing. And then game piece type and scoring location, like this, the location order, that's very, very difficult to track. And I mean, depending on how complicated your scouting system is, maybe you can do it. But then also you think, does it confer a lot of value? Because you remember that you have 10 points of data in terms of location order, just because they play 10 matches. And can you determine a pattern from 10 actions? And is it valuable enough to keep tracking? So this is why we think it's difficult. We're not saying give up on it. We're saying, okay, fine, it's hard. Can we brainstorm some solutions within our team to try and find ways to track these? Do we have some creative way of understanding how this works? While, of course, keeping in mind the complexity factor. Do we want to make it too complicated? Do we really need it? And you kind of weigh and you do a cost benefit of, is it worth all the effort to determine what we get out of it? Cool. So in terms of the final piece, so when you put all that together, you have every piece of information you need to understand a robot. And then ultimately, all of this comes together to give you an informed prediction of what team can do for or against you. And I think the against you point is easy to miss, because you are always watching for things that you want in your pick, but you have to play against other teams. And so if you can use information to create a picture of who you're playing against, it can really help you when deciding how you go about playing another team. And I think this point's important. It answers infrequent but important questions. So how many had points did they get? How many cargo did they score? Important and frequent question. But sometimes there are some more subtle things that come up that you're like, they decided to go for a rocket, but in the 3 matches where they tried to score on the cargo ship, they did really well. That might mean that they are actually a good cargo scorer. So it's an infrequent occurrence, but it's an important question to ask, because in elims, the rocket ship doesn't matter as much. And finally, it captures performance across different strategies. Everyone plays the game differently. Everyone has a different approach. And what you want is the information you capture to be able to predict performance regardless of how a team goes about things. And so this is, again, where you approach the solution seeking with an open mind, so that you aren't biased towards thinking about the game the way that you do, but you are opening up the possibility of tracking performance no matter how the game is played.
Okay, so historically, our team hasn't used apps, and we've done everything on paper, and it's worked very well for us. In theory, it's totally possible to track all these things on paper. It's a lot of effort, but it's in theory possible. So I don't want to make it seem like an app was necessary to do this, but in that year, we decided that an app would have been the best solution that we had, given our resources and given the information that we wanted to track. I also don't want to pretend like we had incredibly high resources for developing an app. We had, 1 or 2 exceptional mentors that were able to lead it, and then a number of students that were working on it. But it's not like we have some great app development team. And the tools these days are good enough that you could reasonably build a scouting app, or you could reasonably take, an off-the-shelf scouting app and work with it with 1 or 2 mentors or 0 mentors and 1 or 2 students in theory. It's totally possible. I don't want to seem like this is a high resource solution, so that it doesn't seem off anyone's radar. But anyway, the app that we decided to build is going to be demonstrated. And if you want to see more about this app, there was a presentation yesterday by Caleb Meck, the lead designer for this app, who talks about exactly how everything works with this. So this is how our app works. First, we capture information like what teams were on what alliance. We capture what the starting configuration was. So did you have a hatch or did you have a cargo? I'm just going to pick random things to show you quickly how this app works. And again, if you want to know more, go to Caleb Meck's presentation yesterday. Position where you start is tracked. The HAB level that you start at is tracked. Anyway, and you can start the match, and then the timer starts. Every time that an action is taken, it changes, or sorry, it inputs that into the app with that timer on it too. So if you drop a game piece, you've just dropped a game piece here. If you pick up a hatch panel, pick up a hatch, then you go and score it in the home zone. Then you pick up sorry, that was the location where you picked it up. And then now you're in scoring mode. So you're scoring, let's say, the rocket in the middle. And did you do it? Yes. Great. Get a cargo. Go to, from the HAB zone, go to the rocket top. Score it? Yes. Get a cargo. You drop it? Sorry, you picked it up from the HAB zone. And you dropped it. If you're playing defense, the good thing about defense in 2019 is that in theory, you could only send one team and go play defense because of the backbot rule. So if you go and play defense, now you're the one team who's defending. Who am I defending? Well, I'm defending 2056. And now I'm not. And now I am again. Okay, and then I went back home. And then let's say you went to go and climb. Go to climb. I got to level 3. Did I have any partners? No. And then you wait until the timer stops. Or maybe I failed. Oh, I fell out. Oh, I fell down. Oh. Okay. If you want to see a history of all the actions that were taken, at the end of the match, you can edit this history. But for now, when you're just looking at it, so 2056, got some cargo. Stored them in these locations, picked them up in these locations, and this is the time at which all of these actions happened, and then whether we dropped them or not. So I'm not going to stay too long on this. We're going to go back to look at how this tracking translated into information with Shankar.
Cool. Animate. All right. So what we did is we went through, we turned the scouting sheet into an Excel spreadsheet, and then we used it to track data. And this is real data from the championships in 2019. And so what I've done here is a very, very simplified list. So this is tracking just a few things. So how many points you score in auto, how many points did you score cargo plus hatch, how many climb points, and how many foul points. So very, very simplified view, and I've sorted this for total match score, and this is the top 15 teams. And so you get a pretty complete picture from having very little information. And I think this is just a point to share that you don't need to track everything to be able to get a decent enough picture to help you with scouting. And so I think Oliver's point there about resources and how you use an understanding of that to determine your solution is important. So if you track very little and you sort by what's happening, here's what you see. So you can see that in column in the auto total point scored, you can see there's a clear disparity in auto point scored between the highest and the lowest. So 26 is scoring almost 15 points a match in auto, while Team 78 is just doing 6.7. And then in terms of who's scoring the most hatches in cargo, it's a clear difference, and there's a pretty strong correlation between who scores well in terms of cargo and hatch versus who scores well in the match. And you can see 1114 is clearly the highest score there by a difference of 3 points. And it's not subtle because the gap between them and anyone else is 2.5 points. It's a huge gap there in terms of how well they're doing compared to everyone else. Climb points you can see again. So 1114 killing it 12 points a match, which is the highest you can get, where 1241 had just done 4.5. So what is it that's preventing 1241 from getting more points? And then how does that picture change if they're able to get from 4.5 to 6? And then their score jumps up by 1.5, and they're suddenly the third best team in terms of match score per game. So it's a picture you can say, okay, so what have they done? Were they missing climbs? Were they trying to score more? Had they just kind of slid off? So it's kind of the question you ask to try and get a picture of what's going on. And then finally we had foul points, and you can see that Team 987 is averaging 1 foul point per match. And as a team that cares a lot about one single point, that 1 point is an interesting kind of note. It's like, okay, well, they do really, really well, but they cost themselves a point a match, which can cost you a championship. However, if we expand this and capture a little bit more data.
I want to check with Emily. Do we have any questions that come up for the previous sections? Because we just barreled through.
I don't see any questions that come up, but Emily can confirm. No questions, says Emily, so we can continue. Yeah, we have barrel through. Apologies. Cool. So then this is the list of the top priorities we talked about. So if I just go across in terms of what we tracked, so we tracked total auto points scored. So did they cross an auto? How many points are they scoring auto? How many tally up hatch successes and cargo successes have they had, resulting in certain numbers of cargo points? Tally up conversion rate. This is just an interesting stat we put together. It's basically what percentage of started cycles resulted in a score. Climb points, so how many points are they climbing, and then foul points, so regular fouls, tech fouls, and the total amount. So if we look at this, so who's not crossing in Sandstorm? So we can see that Team 1023 is averaging 3 points a match in Sandstorm, and this is just crossing the line. So this is a bit of a worry to note that they're not crossing as much as you would hope, and that's a lot of points to leave on the table. Who is the hatch and cargo pro? We can see that Team 2851 is averaging 4.8 hatches per match, which is the highest on the list, but by a decent advantage. And cargo, we can see that there are two, again, kind of diametrically opposed. That Team 78 is doing 7.1 cargo a match. Huge numbers. Meanwhile, Team 230 is just doing 2.8. There's a big gap there. So it's interesting to know that Team 230 is in the top 15 points per scored, but they're just doing 3 cargoes per match. They're doing 4 hatches, and maybe that's where maybe their focus is on hatches and not on cargo, but there's your disparity there. What else does the data show us? Whose cycling is inefficient? So you can see Team 230 is only converting about 4 out of 5 cycles that they start. And I mean, we care about efficiency. We talk always about how you want to make sure you convert the piece that you pick up, because pickup and scoring is a lot of time. So if you start a cycle, you really want to finish it, because if you make an error, the setup time to go back and do it again is huge, and you're losing valuable points there. And so it's a consideration to think about. We're losing a lot of points because they're dropping pieces or whatever the situation is. And finally, we noted that 987 had that -1 points a match. But what we see actually is that they got a tech foul once. And I think suddenly it becomes less concerning, because we worry a lot about averages, but sometimes it's important to dig in to understand what happens. A tech foul is -10 points, and they got a tech foul once. So it's not that they're regularly getting fouls, they got 1 tech foul. And as long as it's something that they're now aware of to avoid the issue, my worry about losing a point a match from them is suddenly gone. And finally, I think we have an interesting kind of table we have in our summary page, which gives you the performance of each team per match. And this is just basically where do teams start and where did they score. So the left is where are the cargo ship scores going. So in auto, this team scores an average of 1 on the front, and then there's 16 on the side. In terms of the rocket, this is clearly a high-scoring rocket ship team. So you can see that in auto, there's a lot of low scoring on the rocket, and then in tally up, it's pretty distributed. Like you can see that the middle is the highest, but the gap between the middle and the low and the high are not that far off. So this is a very quick look at location, because that was one of our priorities to consider. So where the score is coming from, and you can see this is a rocket team. So it kind of makes you think, okay, well, do we think that they can the cargo ship? Yes, because they've got 16, but they're clearly a rocket-focused team. Cool. So we talked about locations, and when we mentioned there are 22 different locations in terms of where you can score, which is a lot of things to watch for. So I put up all of the data we have on attempts and successes at the different locations. We didn't go specific by location. We did cargo ship front, cargo ship side, and then the 3 different rocket locations. And this is clearly messy when you combine it with all the other data. I had to put a different sheet up just so you can see. But if you want to look at it, it's available. And so if we just pop it open and do some insights in terms of what the spreadsheet tells us. So there are a couple of clear cargo side leaders. So cargo side has 4 on each side, and the front only has 2. So you can see that Team 78 and Team 1807 are clearly the team to turn to. They scored 3 per match on average on the side. So if you're thinking we don't have to worry about them not showing their stuff because they're clearly scoring, you know these guys can score cargo on the sides without a problem. Meanwhile, 2851 has done less than half. So they've done 3 and they have 10 matches. So it means that it's clearly not a focus for them. And if you scan across their line, you can see their focus is clearly their rocket. What else does it tell us? So the leader of the scoring, so 3.4 is the highest per match for a team on the low part of the rocket. But you can see that they've never scored higher. So they are the leaders because they only score low on the rocket. So this is important to know because you know, okay, fine, they can light it up low on the rocket, but it means that once the low has been scored, they're not able to do anything. So you can leave the low for them to score 4 balls, but after that, they can only score on the cargo ship. But considering how many balls teams are scoring in a match, that's probably sufficient. But when you pick them, you have to know what you're getting with them, that they can focus and do 4. So they can take care of the rocket pretty much on their own by going low. And then similarly, there are more attempts and more successes on the high rocket. I think Oliver, one more. Cool. So you can see that team 1023 is not scoring very much low, but they're very much going high. So you can see they're scoring 3.1 and 3.3 on the mid and the high, and you can see that team 20 is doing 2.3 and 2.9. So all of the focus has been on the higher part of the rocket. So you can imagine that 2 of these teams together would make a good combination because 967 is going to take care of the low part, and then 1023 or team 820 will take care of the higher bits. So that's kind of your tell. Where are the balls going? They're going high for 2 of the teams, and one is going strictly low. So if you wanted to track location, you can, and you can clearly put together a very good picture with all of this data about what happens with the teams. But again, this is very much a resource-focused question because it takes a lot of effort to be able to track and split up like this. Cool. And then so we have like a.
Sorry, I just want to say one more thing. This information is not just used for picking. This is also used for planning strategy during a match, during qualifications, which we highly prioritize on our team. If you want slightly more information about this, you can turn to our 2018 presentation, I believe, which is on this topic. We're not going to talk too much about it, but a quick example is if you're trying to do a rocket in teleop and you want to split it between 2 teams, you're gonna if you have 967 on your alliance, you know that they can't go higher than the low. So maybe they can be assigned to do the low parts of the rocket, and then another team does the higher parts. Or maybe you have a team like, I don't know, 230. We know that they aren't so great high on the rocket, but they're totally passable on the middle part, and then great on the low part. So if you want to do a rocket with them, maybe they are assigned to the low in the middle, and another team shows up and does the high part of the rocket. You need this information as well to plan for qualifications, so that you can seed highly and you can control your fate, which is something we prioritize. Or you can just win the match, which is if your priority is to win your regional or your district event, you still need to be able to win all these these qualification matches. And without this information here, you can't really make effective plans to most efficiently get your RPs, get these objectives.
Cool, thanks, Oliver. And actually, I had another thought about looking at that because you know that you have 2 high spots on one rocket. So you're looking at 1023 and you know they're doing 3.3, which means that they're focusing on the second rocket as well as the first one. So it means they've made the decision that they want to score higher on the rocket, and maybe that means that they're missing out because they've got 3.1 and 3.3 on the mid and the high. It means that they're focusing on both rockets. And if we talk about that RP game we mentioned early on, you can tell that they're not. Maybe they've had really good partners. They've been able to fill both rockets, but probably the focus has not necessarily been strictly on getting RP, but winning the match. Cool. So this is like a lot of the full details. I call it the full Monty because I've taken the totals out and I'm looking at a lot of the granular details. And I'll kind of quickly flip across the headers and say, so what is your auto cycle time? How many cycles you complete in auto? hatch points scored, cargo points scored in auto, then successes of telly-up and hatch in telly-up, how many drops while defended in terms of climb time, how long does it take you to climb, when did your last cycle complete, when did you start climbing, and then in terms of some errors, so fouls, tech fouls, open field drops, and D scores. So a couple of interesting other points that we talked about as being priorities that you can now take a look at. So if we flip across, and what does this show us? So in terms of first auto cycle time, so you only have so much time available in auto, and how many seconds does it take for you to take care of your first cycle? So you can see there are a couple teams there that are very, very low. So team 26 is in 5.05 seconds, and team 1807 does their first cycle in 4.94. So when a team comes to you and they average 9.78 seconds for their first cycle, and they say they can do 2, you should think about that claim a bit skeptically, because you know that it takes them almost 10 seconds to complete one cycle. Are they realistically going to be able to do a second one before time runs out? Second point, are there drops under defense? So you can see that team 230 averages 0.7 drops per match when they're defended. That means that 7 out of 10 times in their matches, they dropped while they're being defended. And we noticed that they had 2.8 telly-up successes on cargo. Perhaps those are related. Perhaps because they're dropping balls, they're not scoring as much as they hoped. And again, we saw that the low conversion rate was about 4 out of 5. So maybe there's a relationship there. When they're defended, they drop, and therefore they don't complete as many as they hope. And again, when you come to eliminations, you know defense picks up big time. And so if you're looking for teams that can perform well, this is one of the proxies. How fast do they climb? So team 2851 can climb in 2.29 seconds. And that manifests in them starting their climb at just 6 seconds to go. So this is a clear indication that because they know they climb fast, they can wait until the very, very last moment to climb. And if you're talking about a 10-second cycle time, maybe you can sneak 2 more points in before you go for your climb, and that could change your outcome dramatically. On the flip side, how much time is there between finishing your last cycle and climbing? So you can see team 2767, on average, their last cycle was completed at 28 seconds. So that means the 28 seconds on the clock when they stop their last cycle. And then they start climbing at 9 seconds. So what are they doing for an average of 19 seconds between when they stop scoring and when they start climbing? Are they playing defense? Are they considering what they can do? Or is something else going on where there's some idle time in there? And so this is an important question, because we just talked about how a fast climber can sneak in a last score before they go up for climb. But here you have 19 seconds of idle time, which you can hypothetically think is another cycle, is another 2 or 3 points. So what's going on? And then a couple other ones. So drops in the open field. Are you dropping pieces? So we can see a couple teams there averaging basically a drop in match. And that could be a result of some of the stats we're seeing. And then D-scoring. So are you knocking off a hatch in the process of scoring, which is going to cause errors? So we talked a lot about scoring points, but we also mentioned what are you doing that prevents yourself from scoring. And these kinds of errors that you track to understand what might have gone wrong that resulted in a lower score, a suboptimal performance, gives you that vision. And it's key to understand these actions as much as it is to know how many cargo points you score. So I was going to go culture, but that's basically a quick overview of what our spreadsheet looks like and what you can kind of gather. So we talked about the priorities and deciding what's important, deciding what to focus on. And I think if you look at the spreadsheet we ultimately had, we covered off a lot of those 16 items, not all of them, but a lot of them. And we decided we want to capture all of it. And you may learn at the end of it that you tracked data that wasn't helpful. But because we talk about that important but infrequent question scenario, we tend to err on the side of capturing too much information and then going with it and maybe needing it, then capturing too little. Of course, more information is better, but again, this is very much a resource-based decision in terms of how you go about things. Oliver, over to you. Oliver, I think you're muted.
Thank you. So a quick note about culture, which comes up a lot among teams, most of the places around the world. I think Canada has done a good job of creating a culture where scouting is really important. But the way that we've done it throughout Canada is really from the top. So understanding the value of scouting. A lot of the mentors from Canadian teams have worked with many other Canadian teams where scouting has been really important, and we've seen the impact that it has and the success that you can have from scouting. So when you can see the impact of it and you feel like what you're doing is valuable, it's really easy to dedicate resources to it. But if you can't and you need to develop that culture more from the beginning, you still need to work within what your team's capabilities are. So, take a realistic look at how many students you have and how many mentors you have to dedicate to scouting. And, you have to do the best you can with the resources that you have. And if you don't have, data analysis experience, if you don't have app development experience, if you don't have any of this experience, you still need to, try to do the best you can with what you have. Maybe you can only do maybe you can work with an off-the-shelf scouting solution, and there's a lot of these days that teams put out. Or maybe you have to do something really basic with pieces of paper and not even use a spreadsheet. If that's your resources, then you have to be realistic about that and work with that, and build up the culture from the bottom using that information to make the best decisions you can, and then justify the fact that you had this information. If you had better information, if you had more resources dedicated to it, then you could have made better decisions. But based on what you have, you did the best that you could with what you have. And these days, the off-the-shelf scouting solutions that people put out are actually very, very good. Like you would have a hard time, having a better solution than a lot of what these teams put out. So I wouldn't feel any, I wouldn't have any problem with using one of those solutions if you're not going to dedicate your own resources to it. And then in terms of the importance of scouting and using these systems and doing this analysis, when we first developed a presentation like this, when we first started giving these presentations, data science was just kind of an up-and-coming industry. These days, it's a massive industry. It's one of the biggest industries in Silicon Valley. And there's billions of dollars being invested into systems that aren't really fundamentally more complicated than what we're doing scouting robots here. I mean, there's more data going into it. There's sometimes there's like broader societal implications to it, but fundamentally what you're doing is you're looking at a problem, you're asking questions about it, you're asking yourself what information you want to know, and then you're figuring out a way to get that information and analyzing data to get there. So it's not that much different from what we're doing here in scouting. And I mean, that's the career implication. If the purpose of FIRST, as we know, is to create a culture where people value science and technology heroes, if you're doing scouting right, you are doing a microcosm of what data science really is. And it can be as big or as small as you want it to be. And a lot of teams these days are working with really complex solutions, using a lot of data, putting more complicated things together. And as FIRST gives us more metrics to work with, as Zebra MotionWorks maybe comes out in Canada, we're going to see that there's so much more data coming out, and there's so much more interesting stuff that you can do with it, that you can really develop a data science skill set, many years before other people can develop it, because you're doing it in high school. In grade 9, you're doing data science. That's a massive career advantage that you can be giving to the students. And the other important thing is when you're collecting this data and you're relying on it, you really need to trust it. And this lets you make unpopular decisions or innovative decisions that maybe you wouldn't have been able to justify otherwise. Maybe you can justify picking a team or assigning a team to do a task that otherwise it would have been tough to justify telling them to do, or maybe you are picking a team that would have been unpopular, but your data says that they're going to bring you success. And no matter where you are on the picking order, if you're able to make these decisions and you're able to make the right one, no matter how popular it is, or no matter how you might have to justify it to your team, if you have the data to back it up, that makes your job a lot easier, and that's gonna lead you to be making decisions that are going to make you a lot more successful. Cool. So now we're going to shift to a case study on Infinite Recharge, the game that we just played, but most of us didn't actually get to play. I realized that we should probably have the game animation for this, because to be honest, I don't even remember that much about this game. We did this analysis. Let's just make sure that we're all up to date about how infinite recharge works. That's not what I wanted. Great.
Welcome to the 2020 First Robotics Competition, and this year's game, Infinite Recharge. An incoming asteroid shower is aimed at First City. Using Alliance droids, planetary citizens collect and score power cells, while traversing the trench run and boundaries to ensure maximum protection with an operational shield generator. Droids start on an initiation line, and may be preloaded with up to 3 power cells. Droids operate autonomously during the first 15 seconds, an attempt to store power cells into any of their 3 available power ports. While every power cell deposited adds equal charge to the shield generator, higher power ports earn more points. Drivers then control their droids for 2 minutes and 15 seconds of teleoperated time. Power cells earn more points. Drivers then control their droids for 2 minutes and 15 seconds of teleoperated time. Power cells are collected from one of the 5 chutes in the loading bay, and then driven across the city to be scored in the low, outer, and inner ports. Droids must score the required number of power cells to activate sections of their shield generator, and then either rotate their control panel a specified number of times, or position it to a specific color. Near the end of the match, droids race to their rendezvous point to make their shield generator operational. Alliances are awarded bonus points for a level generator switch. The alliance that earns the most points wins the match. May the Force be with us all.
Endgame RP for scoring a whole lot of balls and doing the spinning objectives. Can I get some confirmation from someone that you can hear me? Great, okay.
Yeah, Oliver, we're good.
I cannot hear any of you, though.
Can you hear me?
I cannot hear you. Oh, my system muted. Oh, that's so odd. Why does it do that? It just muted my system sound. That was a completely solvable problem. Anyway. Case study for infinite recharge. So we're going to do the same game analysis. Are there any questions at this point? Can we confirm? Oops.
No questions, I think.
Okay. Can we get some participation from OP then? Everybody, it's time to participate. You didn't sign up for this, but you're going to participate. All right, for now, until people realize, we're going to have participation from Shankar. Shankar?
Yes.
So we've just been released with a new game. What do you think?
A lot of stuff going on.
All right, so given this new game, what can we do to directly score points in this game? Excellent.
We can score balls.
Score balls.
In 2 different locations.
Are you sure?
Three different locations.
What else can we do?
Is it all me? Okay, we can hang.
It's all you for now. You can hang.
We can
What else
hang
can
and
we
we
do?
can level.
Oh, we can level too.
And we can spin a wheel.
Spin that wheel. Okay, what can we do to enable? Sorry, let's move to the answer key really quick. Bam.
Oh shoot, I missed auto. Of course, we can.
Oh
move.
yeah, the auto line. Excellent. Okay.
I'm very good at this. Can you tell?
Oh yeah, balls in 3 locations. Great.
Okay.
Climbing. Oh, you can park too. You can park. Parking
Fine, hang
points.
plus park. I would say this is analogous. Okay.
Okay, moving on. Where can we do all these scoring actions? Hey Eric, where can we score?
We can score.
Where are we?
Oh
Yeah,
boy, I'm losing my train of thought. What is it? We can score in the shield generator. Shield generator, hang. Yeah, we already mentioned that. And okay, there's one more. I'm sorry, it's been 6 months since I've gone over the game manual.
That's okay.
We just showed you the video.
I just showed you the video.
And I did. Oh boy.
Hang bar.
Yeah, I mentioned hang bar.
Great. Okay. What can you do? Hey Eric, what can you do to enable some points to be scored? We already talked about picking up balls. What else can you do that directly leads to points being scored but doesn't score points yourself?
We can spin. We can spin the. Okay, what's the name of it?
It doesn't matter. You can describe it to us.
Describe it to us in general terms.
We can spin the panel.
Spin the panel.
Control panel. That's what it's called.
The control panel.
I don't think that's enabling points. Come up with another idea.
All right, gets you toward rank points. Okay.
That's fair. I'll give you that. Control panel.
Right. Oh boy.
I mean, if you think about how you. Nice.
Oh yes. Let's check the answer key. You can acquire balls. You can. Oh yeah, your robot would have to sort the balls because this is a year when you can pick up multiple balls. So getting the ball into the scoring position in your robot is good. Unless you have 3 channels, you're good. Then you don't need to sort the balls. You can ferry the balls. So you can bring the balls from one side of the field to the other to score them. You have to drive the balls, and then you can pick up other teams. You can do a buddy hang. That remains to be seen how often that's going to happen. Okay, what about locations, Eric? We talked about the ball scoring locations, the 3 locations. We talked about the shield generation, and we talked about the hanging bar.
Yeah.
What other questions might we ask about locations where things happen?
Where what is a possibly good angle to shoot, especially to get into the inner port? Because you have to be in a certain location depending on your robot to be able to shoot in whatever port you want to.
That is
especially if you're aiming for the inner port.
Okay.
Right.
So where can we get the balls? We can ask. We didn't talk about that. The rendezvous, you can get balls from the rendezvous as well, and they're put there in set locations that you can get in autonomous and in teleoperated mode. You can get them from the trench. You can get them from the overflow hole. So when teams score too many balls, you get more balls for yourself. You can spin the wheel, and then like Eric was talking about, the shooting locations also very important. So you can divide this up into as many or as few locations as you want. It remains to be seen what we're going to do because obviously we have not played this game yet. But some of the key locations are you can score from the protected zones, you can score from behind the wheel, or you can score from the left or from the right or from the head-on. So Emily, what can you do that cause your opponents to not score any points? Emily, who I saw was here. Thank you.
What can we do to cause our opponents not to score points?
Yes.
We could defend their their rockets.
Oh, sorry, this is for 20.
Sorry, not rockets. Yeah, defense. Tyler in the chat just said defense.
Defense.
Thank you, Tyler, in the chat.
Now, what else can you do with it? So more specifically, what kind of defense?
What are you trying to stop?
Stop them from shooting the power cells into their oh shoot, I just forgot the name of it.
Shield generator.
Thank you. The shield.
Called the shield
I don't think it's called. Wait,
No.
no.
I don't think it's called the shield generator.
No,
Oh.
wait.
Everyone watching, you will forgive us. We did not play this game, and we just watched the video for a different game.
PowerPort.
No.
Oh yeah, PowerPoint.
Ports.
Okay.
Ports.
You
Yeah.
could 5406 Dad in the chat just said steal their balls.
Nice. We like stealing.
Okay, so
What-
let's see what we. Sorry, do you have any more ideas, Eric?
Or how specifically would you steal the balls?
How you answer that question? How specifically would you steal the balls?
Well, any balls that may be available on the ground, you could run off, or you could slamming into them and block access to the balls.
Sure.
I mean, it's against the rules to actually dig the balls out of the robot, since that would involve direct contact
Yeah.
and possibly extensive damage.
You
Well-
could zone defense or block shooting locations online.
Yeah, Eric, on the balls, I think we were talking about sometimes people assume that balls are assigned to an alliance because they're in a certain position. So if we go and take the balls away that seem like they're the other opponent, the other alliances, then you're making it easier for you to score and making it harder for them to score.
Yeah, especially the rendezvous location balls.
Yeah, I think rendezvous is a big one. That's the one you steal.
So we got, in our initial brainstorming, we got, you can block them, you can clear balls from their overflow or the loading zone, you can get the balls from their side of the field. There you go. And then you can create a clogged rendezvous by taking up space. Oh yeah, so if you take up space, this is kind of the zone defense point. If you take up space in the rendezvous because it's hard to traverse, it makes it harder for opponents to go and get balls. And then in our brainstorming here, I think we covered all those. Okay,
Nice,
what
we
about
did well.
stopping? Good job. We brainstormed the same things on the same team. Causing
And the
yourself
chat. We
to
had some chat participation.
Oh yeah, and the chat.
That's most of what I said was participation for the chat.
Yeah.
Oh, so they're not your original ideas, and you didn't attribute them?
No, the defense was my original idea, and then Tyler added that in. So.
Okay, fine. We'll give you credit over Tyler. I think
Okay.
yeah, we like you more than Tyler, so you get the credit.
Thank you.
Oh boy.
So
All right.
causing yourself to not score, what can you do?
Make sure you get it before Tyler does.
Oh, causing yourself not to score.
You can just straight up miss.
Oh
You
yeah.
can
Yep.
shoot from an undesirable location
Nice.
You can
Full court.
jam.
on purpose or accidentally, that is.
Both.
RJ
both.
Coach _3538 said you can jam.
Nice. Yeah.
Except why would you want to not score on purpose is the question.
No, Oliver, I think on purpose was shoot from undesirable location, not jam.
Oh.
I think that's what
You
Eric
could-
meant, because you can be forced to shoot from somewhere you don't mean to, or you may just shoot from somewhere that you don't mean to.
Yeah. I meant it for, yeah, never mind.
That's what you meant, right,
Declare
Eric?
dead ball.
Yeah.
And wait. I have a question that I don't remember. If you declare dead ball in 2014, is your robot prevented from touching a ball in the future?
No, I think you're allowed to. It's a long time ago, Oliver.
Yeah. So could you just strategically declare dead ball and then call
No.
that ball undead and use that ball as a game piece?
No.
No.
I think you were allowed to contact balls, but you were not allowed to pick up more balls. But it's a long time ago, so I forget.
So you're just
I
out
think- I
for
think-
assists.
Yeah.
Tyler said it was a card. To do it
What kind of card?
strategically.
Thank you, Tyler.
That makes sense. What have we got for this one?
Yellow
We can
card.
screw up. You can screw up the control panel. I think you can get the color wrong, or you can spin it not enough. I'm glad we're getting the correct terms now. Clearly, we've adapted to the game a little bit more.
Yeah.
Did they ever change that rule about spinning your opponent's control panel? Like going
Not
in
sure.
and swiping the control panel? I remember there was a rule change about that. I think it might have just been in, and I don't remember.
Don't quote me on this, but I don't think you're able to.
Oh, you could fall. You could fall from your hang, or you could unlevel a hang.
Good one.
Oh, yeah.
Very good one.
Yeah, that's an important one.
I totally watched a lot of matches in this game.
We all
Yes, we
did.
did.
We just don't remember
Well,
them because
I didn't. I didn't watch
so
any
it's
week
like
one.
we're looking at this with fresh eyes, right?
Yeah.
So, oh, we have so many.
No, I think we
you could get a 2 instead of a 3. Look at that.
Oh, yeah, okay.
Decent.
You can jam yourself. You can spin the wheel wrong. You could fall.
Yeah, we got most of these. We got most of
Balance
these. We
it.
just missed a 2 instead of 3.
Oh, yeah, you could spin the wheel when you shouldn't be spinning the wheel.
Oh, yeah, this is an inefficient. Well, this is more of an inefficient thing than okay, fine.
Yeah. Or you could just spin the wheel incorrectly.
Yeah, that was on the list though. We put that down.
Yeah.
And then so going through a clog. So then we mentioned a way to stop points was to clog up a zone, and the same thing could happen. You could go into a clogged zone, and then you could become less efficient at scoring. I'm
If
just
you
reading
run
off the list.
yourself into inefficient locations, you're gonna score fewer points, and it's gonna be your fault. And then, was there anything in this game that could have scored points but didn't? Truly, we did this analysis like yesterday to prepare for this, and I already don't remember. So this is very, very good new eyes analysis. Could have scored points but didn't.
No, I think we said this one was really hard. Right? Didn't we do it was hard?
Could have scored points but didn't.
Yeah,
this is
actions
the inefficient.
yeah, deliberate, inefficient.
I think spinning the wheel. I would say spinning the wheel's one, right? You try to spin the wheel to get RP and points, but you are not good at it. And instead, you should have just scored, or you should have hung. Because I think you spin the wheel instead of hanging, and then you're just risking a lot to spin the wheel.
Yeah. Or just spinning the wheel generally. Because it was so few points for such a long time, and teams didn't show that they could do it efficiently.
Shooting from a poor location again from King of Chaos.
Yeah.
But deliberately.
Okay, Albert, do we have more? I forget what we came up with. What's on the answer key?
What is on the answer key? Okay, my dog is waking up, so there'll be some noise. Where did we miss? Sorry, we missed this one. Oh yeah, thinking that you're the Penguineers. So in 2012, the Penguineers were one of the best, if not the best team in the world. They could score, 20 some balls, and it was a ridiculous number. And you got 20 points from being on the balance, but the Penguineers were so good that they could score 21 or more points from not balancing in the time that they would have spent balancing. So thinking that you're the Penguineers and that you can score more points than you can get from balancing when truly you cannot. That is an example. Or maybe you are the Penguineers and you're deliberately doing that.
Current.
Yeah, I think we covered all of that except for shooting from a poor location, because I guess in theory you could decide to shoot from full court or another location when you could have scored from a different one, but you decided to do that deliberately for strategic reasons. Okay. Yeah, I hope that felt relevant to everybody, this kind of analysis, because it gives you a better picture of all the actions that can be taken, as well as all the things that you might want to know in that year. So you could look at a team, you could see that they score a whole bunch of balls and they don't climb, and you could ask yourself, well, are they doing that because they chose to? Are they doing that was it correct for them to be doing that during a qualification match when you're with them? Do you want to discuss with them maybe not doing that and maybe climbing instead? Or do you want to discuss with them, hey, it was great, maybe you should continue scoring instead of climbing because your scoring is so great and we really need points this match. Those are two scenarios that I can see coming up that you'd want to know the answer to. So, are we with the Penguineers or are we not with the Penguineers? What are we going to do in that endgame time? And if you don't do this analysis, there's a potential to miss specifically things in this section, which are more nuanced, but a lot of these other points are pretty fine, and you could miss them in an analysis very easily. And then you could miss, the fact that maybe you want to design a robot without a hang because truly you can score 50 points in 20 seconds. It's possible. I can see it happening.
All right, Oliver, I think we're running out of time rather rapidly.
Okay, so we're going to wrap with the last slide of the match, or sorry, the last slide of the presentation. Just to quickly reiterate all the points that were said, to find the answer, you must know the answer. So that means you have to envision how you think the game is going to play out, and then you can do all the sort of ancillary steps. You have to ask yourself, what will I want to know this year? Not what can I look at, not what can I scout, but what are the questions that are going to come up, and what is this small question that someone is going to ask one time, but we do need the answer for it because it's going to be the difference between winning a match or losing a match, or even not just that, but it's going to be the difference between 5 points and not getting those 5 points, or 1 point and not getting those 1 point. You need to capture all this information so that you can optimize your performance as best you can down to the single points. And like we're talking about, if we think that FIRST is a microcosm of life, scouting is really a microcosm of data science, which is a huge career opportunity that you can get a big leg up on if you do scouting and you do scouting well. Yeah, have good data. Your alliance partners will thank you, and you'll be more successful for it. If you want to contact us, all this information will be up on the website. Our emails are here if you have any further questions. But otherwise, thanks so much for coming to the presentation.
Cool. We have 2 minutes for questions if anyone has any questions. Emily, are there any questions on the chat?
So there's one question right now asked by 5406 Dad. $200 billion industry. Does that include the money spent by the government industries like NASA, CIA, NSA, and FBI?
This is a stat pulled from a website, like a magazine, like a Business Insider, Forbes kind of deal. So I'm not sure if it reflects the true size of data science. It probably doesn't. It's probably even bigger.
Cool. I mean, if anyone has no more questions, I think Oliver's right. We'll put all this stuff on the website, as well as our previous presentations are on there. Feel free to contact us. We're more than happy to answer any questions. But if not, again, thanks for joining us, and hope you enjoy the rest of your day.
Okay.
Right. Thanks so much for having us. Did a great job moderating.
Right, so thank you, Shankar and Oliver, for presenting. That was well done. I hope you guys, the audience, enjoyed it.